So, hello everybody. Almost the last session for today. Do you guys still have energy? Yes! That's perfect, cool. Okay, blockers, treasures of improvement is the title of my talk. My name is Klaus. I come from Austria, Vienna, Austria. So that's the other Austria. So that's Mozart, not kangaroos, you know? Okay, and yeah, I'd like to share some of my experience with the topic blockers, okay? And what you can actually do with your blockers. So when we are working in a Kanban system or in a flow-based system, this is a situation we often see, right? So we have two items here in the development activity. Both items are blocked, okay? And in the analysis activity, there's another item sitting in done, but these guys from development, they don't pull it in because they would exceed the WIP limit, right? So that's a valid state, right? If you're working with Kanban, this can happen. So what do we do? Any idea? Yeah, that's very good. Yeah, I mean, there are multiple strategies, right? We could increase the WIP limit, for instance. I mean, who says that 2 is the correct WIP limit here? So if the WIP limit is 3 in development, guys could pull in work from analyze, and we're flowing again, right? What I also see quite often in reality is that people say, okay, when there are blockers, we don't count them to our WIP, so we park them somewhere, okay? So that's another strategy, right? So, but all these strategies like increasing WIP limit and so on, they actually, they actually build on the strategy hope. You know, we hope that these blockers will disappear. So, in the last couple of thousand years, mankind developed some more sophisticated strategies than to hope. Yeah, we could solve them, right? So. We could solve these blockers, and if one of these two blockers disappears, we can continue working, right? Not really rocket science. So the point is, if we see this situation in real life, we can observe that these blockers occur quite often. I hope you can see these circles here, right? So that's a Kanban system actually from one of my customers based in Vienna. And what you can see is that there's quite a lot of blockers happening, right? And if you take a closer look at these blockers, what we actually see is that the vast majorities of these blockers are not singular events. There's a systemic behavior behind it, right? So this blocker here does not occur once in the lifetime of your company, right? It's much more likely that this blocker pops up again and again and again. So a blocker could be, for instance, we are waiting for the test environment, right? That's not a one-time event. Usually it pops up again and again and again. So what do smart companies do? Well, they solve the blocker. Not a bad idea, right? But then they don't throw the blocker sticky away. They take it and just put it on a flip chart. And then they try to understand what do all these blockers actually have in common, right? And then they build some kind of clusters. And all these blockers, they have the same reason. And the idea is that you then solve the reason and not only the blocker. Does it make sense? Yeah? Okay, so if you are in an environment where blockers occur, and if you're working in a flow-based systems, you will have to deal with blockers. Don't throw them away. Collect these blocker stickies. They are really treasure of improvement, right? It's important that you write some reason on this blocker that you can interpret a couple of weeks later, okay? So if the blocker occurs today, it's totally clear why it's here. But if you want to analyze it later, you have to write down some sound reason here. It's also a very good idea to note down the activity. You know, in the development activity, this blocker occurs. And what I also like to do is to put some strokes on the blocker just to annotate how long was this blocker actually active, you know? So for each and every day, just put a stroke on it. So this blocker was active for 7 days. This means it costed us 7 days of lead time, right? Okay, if you do this for all your blockers, then you could do this clustering then, right? So maybe you sit back in some kind of improvement meeting or whatsoever and analyze them. And you will find out that there are some clusters popping up. So here we have a cluster like the blockers were no pictures for customer A, missing pictures for customer B, waiting for text for customer D, and so on and so on. And you could cluster them and say, okay, we have an issue with content. There's always content missing, okay? 109 days lead time. And now you can ask the question, how should we change the system that actually these blockers don't pop up again, right? Does it make sense? Yeah. And that's actually data from a real blocker cluster, what you've seen before. And you can see there's quite a lot of lead time in there, right? And if you solve one of these blocker clusters, you're becoming faster without working faster. And that's what we want to see here, right? We want to have systemic improvements. Yeah? Sum of all the lead times in this cluster. Yeah, thank you for this. Yeah? Okay, so how do we actually solve such a blocker cluster? Well, it's always a good thing if you try to understand the problem. Don't jump to the solution immediately, understand the problem. How do we understand problems? Why is a very good question, right? You know, root cause analysis, 5 why, there are different ways of how you can approach this, but ask a couple of times why. Why the heck are we waiting? Are we always waiting for content actually? Well, maybe it's something like the customer doesn't send it to us. Okay, so why is the customer doesn't send the content to us? Well, often they don't know what we need. Okay, so why don't they know what we need? Well, we don't always tell them. What would be a very smart solution now? We could tell them always, right? I mean, that's no rocket science, right? That's common sense what we are doing here. We could tell them always, and the solution is probably, so if there is content missing somewhere, well, maybe we add some kind of checklist item in the definition of done somewhere in the analysis phase or so that we don't forget to inform the customer. And that's it. And the point is, these blockers will go down, and your work will be finished faster without working faster, right? That's what we want to see here. Okay, so what we've seen so far is blockers, okay? And collect them, understand the problem, find a solution. What else could you actually collect? So when you're working with a flow-based system, we are very often in exactly this situation. Yeah, that's how we are working. So what do we see here? Well, we have a lane of cars which are going here on the left side down the road. And there's another lane of cars which is going up the road. And for what's reason ever, at this point, these guys come to the conclusion that it's better to join the other lane again, right? Except of Chuck Norris. I mean, he doesn't care, right? Well, I think you don't have to study flow management or something like this in order to interpret this kind of picture, right? So the decision that these guys want to join the other lane does not, well, let me put it that way, does not tremendously speed up this lane, right? So it's sure that this will slow down the traffic on the left lane, right? And yeah, well, that's how we are working all the time. This is a situation, maybe in a lot of Kanban systems in in this room here. So what does this mean? Well, on the left side, we have all this stuff that we could deliver to our customer. All these new features, whatever, all this stuff that the customer really wants to see value for our customer. If we deliver one of this stuff, the customer is smiling. Smiling customers is good, okay? Here, on this lane, we have all this stuff that we already shipped to our customer, and then the customer says, oh, look at this. There's a bug. Could you please fix it? Yeah, sure. There's another bug, another bug, another bug, right? Rework. And so we already shipped stuff to our customer, and the customer says, I don't want it like this, or there's a defect. And precisely at this point, we have to make a business decision. And the business decision is, do we want to work on stuff that actually creates value for our customer, or do we want to work on stuff that totally has no value for our customer? This. Nobody says something? I mean, this has, of course, value, right? Because first the thing was broken, and then we heroes step in, fix it, and it's working again. It's tremendous value for our customers, right? Well, I don't think so. I don't think so. Usually, these defects were not ordered by our customer. At least I never ever had a customer who said, okay, please do these 4 features for me and these 2 bugs. They are so awesome, you know. The screen always turns this shiny blue, yeah. I want to see this. No, that's not reality, right? So what we see here is, if we really want to become faster, we have to focus on quality. We have to remove this here, okay? Well, in reality, it's sometimes a little bit different, at least what I see. In reality, we have somewhere a deadline, okay? And we are approaching this deadline, and we're coming closer and closer and closer, and we won't make it. So what kind of decision are we taking? Yeah, we're late. So yeah, let's not be so picky with this testing stuff. We can skip a little bit of testing, right? Yeah, smart decision. You don't save time if you save on quality, because it comes back, right? It's pretty much the same if someone asks me, I want to lose a couple of pounds. Do you have a tip for me? And I say, yeah, donate blood. It's totally the same, right? Everything's coming back here. So if you think that you're working in such an environment, and chances are pretty high, you could model it like this. You could actually do a Kanban system where you basically have 2 swim lanes. One for the left lane, which is new features, right? And a rework lane. And here we have all this Chuck Norris stuff going on, right? And both of these swim lanes, they share a common ready column. And here we have to do this business decision, actually. We have to make a conscious decision what we are putting in into this column. So there's a limit of 6. Is it 2 rework items and 4 new features? Or is it only 1 new feature and 5 rework items, whatever it is, right? But one thing is crystal clear. The more rework items we put on the board, actually, the less features we can deliver. That's not rocket science, that's common sense, right? However, we totally lost common sense in our working environment. That's at least what I see quite often. So make common sense explicit. Make this decision here explicit. And, again, learn from this decision. So if you want to become faster, you have to remove or reduce, actually, this stuff on the board, right? So, yeah, if this is rework, what we see quite often here is that this is work items that yeah, we have to fix a particular part in somewhere in our system, in our software system, right? For instance, that's something, a rework item for the payment module. There's something for the search algorithm. There's another payment model, user profile, payment module, and so on and so on. The idea is that you collect them and do the clustering again, right? Another thing here is that really a large percentage of support requests, they are actually rework. Have you ever thought about this? Whenever a customer calls you and says he doesn't understand something or so, that's rework. Learn from it, okay? So, yeah, from, at least in my thinking, I would model rework and also sometimes support requests as blockers, because these guys are blocking us from delivering value, okay? And if you do this, your cluster is becoming more colorful, right? So put them together with all the other clusters, so the real work item actually, right, on the blocker cluster. And what you can see is probably something like this. We spent 24 days fixing stuff on the payment module. What should we change in the payment module that we don't have to spend this amount of time fixing stuff in the payment module? Okay, does it make sense? Yeah? So use all the information you have on your board. That's a huge information radiator, such a Kanban system, okay? When I'm talking about rework, rework for me is different from this here. So here we have a testing column, okay? And if we find a defect here, that's not rework in my definition. So rework is really stuff that's coming in from the live system, right? Here, it's, yeah, it's in our system, and we can do something about this defect before we deliver it. Jesper, that's what we've talked in the break, exactly, right? So, so this is not rework. But what would you do if you have a blocker here? Well, again, there are multiple things that could be done. What I see quite often in real life is that people are sending the work item back, okay? So it's like, there's a problem, you developers go fix it. There's a problem, you analysts, you have to fix this, right? Well, that's not how I would model it. When I see this return traffic, I try to challenge these guys who are actually responsible for this board, because usually, let me put it that way, I don't say it's wrong, but they don't share the same understanding of what we are actually modeling here, right? I like to model activities, and in the test activity, there's a problem. So let's fix this problem, right? And if you send this work item back to development or so, it's more like, this is the column for the developers, and this is my work, and here, this is the testers, this is my work. And you have to fix this problem. That's not the point of a flow-based system, right? Here, in this activity, we encounter a problem, and let's make it visible. That's the idea, right? Do not send blockers, what is it called? Work items back. Don't allow return traffic. Bug fixing is no new work. That's still work in progress, and there's a problem, okay? And there's a problem. This means defects are blockers. Block them. Maybe use a, what is this color? Blue sticky note, and put the bug blocker actually on the ticket. And if you do something like this, what can you do again? You can put it into your blocker cluster, and you can work on the root cause of your bugs. And that's something that's almost never ever done in software development. At least I don't see it really very, very rarely. You know, there's a bug. What is the expected behavior, fix the bug. Bug, fix, bug, fix, bug, fix. Nobody's asking, what the heck should we change that this bug does no longer occur, right? And if you're doing something like this, you can do it, right? Find out what is causing you problems. If you have something like user acceptance test not passed, and it costed you 90 days or whatsoever of lead time, yeah, well, we could try to understand the problem again, right? Why the heck are we blocked by user acceptance tests all the time? Why the heck are we delivering stuff that the user does not want? Okay, and then we probably find a good solution for this. And usually it's never a lack of solutions. To this problem, user acceptance test not passed, there are probably 20 solutions. You know, acceptance test-driven development, behavior-driven development, specification by example, or whatsoever. It's never ever a lack of solutions. It's always a lack of understanding the problems. People are installing solutions without understanding the problem, which is actually not very smart, right? Another solution could be, for instance, well, we want to introduce some kind of review activity after the analysis activity, because we want to find a common understanding among the participants, actually. So among the PAs, the developers, and the testers. And then, if they have a common understanding, we assume that these user acceptance test cluster goes down. Okay? Does it make sense? Yeah? This is just one possible solution. But the point here is try to collect all this information that is given you by a flow-based system and cluster the information and try to find solutions of the root cause and not only of the problem. Okay? All right, so what have we seen so far? It's a good idea if you are collecting blockers. Blockers, at least my definition, is anything that prevents flow of work items. You could also collect and cluster bugs and defects, so anything that causes some kind of quality problems, okay? What we've also seen already is rework and support requests. Try to learn from rework, try to learn from support requests, and try to improve your system. And another thing that I'm trying to collect quite often is policy violations. You know, in Kanban, there's this practice number 4, make policies explicit. And make policies explicit means strictly follow the policy and always change the policy, right? So you need both of them. But yeah, there's no policy without exception. So from time to time, we want to, or we are violating policies for work items. For example, sometimes we are doing, a peer review or code review, but for this work item, we don't do it, okay? That's a policy violation. Don't let policy violations only occur. Make them as a conscious decision. We are violating this policy, okay? And write it, for instance, that's at least what I'm using, such an orange, that's orange, just for your information. Write it on an orange sticky note and attach the sticky note to the work items, to the work item. And then put them also in your cluster and try to learn from your policy violations. Why the heck are you violating these policies? Maybe we have to change them, okay? Does it make sense? So, right. That's where we are. Now, let's take a look at this. We have a couple of clusters now because we are collecting all this information, and that's totally awesome, right? So we have this like content missing, 109 days are bound in this cluster of lead time, waiting for user experience, review are not available, and so on and so on. So we have quite a lot of clusters. If you're doing this blocker clustering, that's the situation you're in. What cluster should you solve first here? Content missing. Sounds obvious somehow, right? Because here we have 109 days lead time in there. Could be a good idea, but not necessarily. Okay? Why? Well, actually, often we are biased. We are biased when it comes to the question, what kind of cluster do we want to solve? Well, often it's the one with the highest lead time. I mean, that's obvious, right? 109 days, that's better than 11 days. Well, we will see in 2 minutes, not necessarily, okay? Maybe we are also biased like the ones we own. Our blockers, we are under control. We can, put a solution into place. That's awesome. We should solve these blockers. Maybe. We will see. Or the simple ones. That's a good one, right? So we understand this, and it's easy to fix, and we want to see quick results. So let's fix this blocker cluster. Also not always the best idea. And what I also see quite often is the most recent ones. So they are still fresh in our memory, right? Well, these are some biases, and they don't necessarily make sense, right? So just a couple of ideas of how you could evaluate what kind of cluster you want to solve here. Well, first is fix only these clusters that are constraining the system. Fix only these clusters that are constraining the system. What does this mean? Well, let's assume we have these 3 clusters, right? We have this cluster waiting for user experience, content missing, and test environment not ready, okay? This is our Kanban system. So we have some kind of analysis, development, test, and remember in the beginning, I said it's a good idea to write the activity on the sticky note. If you did this, then you will find out something like this, that this blocker cluster, the majority is actually blocking most of the time development. This one is blocking analysis, this one is blocking test. Okay? Does it make sense? Okay. That's a good thing. So the statement here is fix only clusters that constrain the system. What if this is the state of our system? What cluster should we solve? Test. Yeah, right? Because these guys, they are done, right? Here, there are a couple of tickets already done. So what's the point to solve this cluster here, content missing? Doesn't maybe affect totally nothing in our system. It's maybe like we are overloading this constraint here even earlier, right? So it's maybe not a good idea to solve this one. Maybe it's a good idea to solve the test environment here. And for this one, what should we solve here? Development, yeah, exactly. So the point is really find out where there is the constraint in your system and target on these blockers or these clusters that are where the majority of lead time is in the constraint, because then you are getting load off the constraint. So the problem here is that's if you only take the board into account, that's only one situation. This situation could change after a day, right? So what kind of data should we use in order to take this decision? Any idea? So let's assume we after 4 weeks, we have 4 weeks of blockers somewhere lying around, and now we want to find out what is actually the constraint in our system. What kind of data should we use for this? Or what kind of metric could we use? Cumulative flow diagram, right? So analyze your cumulative flow diagram. And when you see work is piling up in done, for instance, in analysis and in development, in progress is always very full. And that's a pattern over a couple of days, it's a recurring pattern, right? Then the chances are high that the constraint is here, for instance, in development. And then you can target this one, right? So cumulative flow diagram is actually a quite nice way to find it out. And don't be too, don't over emphasize constraint actually, because in knowledge work what we see quite often is that constraints are, of course, moving around. And that's a good idea if you take the cumulative flow diagram, because you get a longer time frame to analyze it actually. Okay, so again, we're talking about the question, what kind of cluster do we want to solve? So the first statement I did here, fix these clusters that constrain the system. Right, good idea. Second one, weight the resolution effort against the blocker impact. What does this mean? Well, again, an example. So let's assume we have these 3 blocker clusters in our system, okay? So we have content missing, 109 days, and the solution for this cluster is something like a definition of done item, which informs the customer about content, okay? So that's the solution for this cluster. Then we have another cluster like reviewer X, whatever, it's a person or so, or a group, right? It's not available, 11 days. The solution is that we talk to this reviewer and to find a solution actually with him, because it's an external resource, so we have to approach him and have to figure out a way how we can lower actually the waiting time here, okay? These are only possible solutions. Of course, there is unlimited number of different other solutions. And we have another problem here, waiting for backend. 87, I think, is this number, days. And the solution is that we merge our backend and front-end team, or restructure the teams actually, so that this blocker cluster does not occur again. Okay. As you probably know, each and every problem on this planet can be represented in a 3x3 matrix. And even this one, right? So maybe you have this 3x3 matrix where one dimension is time blocked, meaning the amount of time that is blocked, and you find actually 3 categories, like for instance high, medium, and low, okay? And you have something like solvability, so actually how easy is it to solve one of these clusters. And you have easy to solve, moderate, and hard to solve, okay? So what cluster should we solve first in this matrix? Yeah, high and easy to solve, right? That's our number 1. Our number 2 is probably medium time blocked and easy to solve. Number 3, high time blocked, moderate to solve, and so on and so on. Okay? And now, in our blocker clustering meeting, we sit together, and now we can actually use this matrix just to assign the blockers or the clusters to this matrix. So, what do you think? Content missing, 109 days compared to 11 days and 87 days. Time blocked is definitely high, right? Solution, put a definition of done item and inform the customer. That's easy, right? So that's probably a 1 here, okay? Then reviewer not available. Well, 11 days, it's definitely somewhere here. Time blocked is very, very low. And maybe it's moderate to solve because we have to speak to this guy and so on and so on. Maybe it's an 8. I mean, maybe it's a 7. Who cares? We have a 1 here, okay? And this one is probably a 5, okay? And the point here is, it's not about to find out if this is a 5 or a 4, if you have a 1 here, right? You can be quite, if I have a 1, it doesn't matter if we have a 5 or an 8 here. Be pragmatic with this, right? That's I really love my friends in Switzerland, but it's sometimes really hard with them. You know, it's like, yeah, but that's not a 5, that's a 5.5. Like, who the fuck cares? We have a 1 here, you know? Yeah, okay. So, yeah, easy stuff, right? Okay, so number 1 was only fix the constraint. Number 2 was weight resolution effort against the blocker impact. This can be easily done with some kind of matrix here. So here we should fix the number 1 first. That's it, okay? The third one is think about economics. Yes, I think especially in the software industry, we are not very good in economics. Well, if you talk to a developer and you ask him, why did you do this? And he says, because I can. You know, that's CV-driven development. That's maybe very helpful for the CV of the developer, but in terms of economics, it's useless. Don, I think that's a quote from you, right? You may ignore economics, but economics won't ignore you. So true. Yeah? Okay, so let's bring some economics in here. Well, the problem is user acceptance test not passed. Well, 92 days, that's quite a lot actually. It's nice. So the solution is we should introduce this review activity after analysis, right? Cool. So this is how our system will look like, okay, if we want to solve this problem here. So we add this column on our board. Is this economically meaningful to do this? Do we know this? Well, let's think about it, okay? Well, if we add this column will actually add, so this additional column here, this review column, will increase the lead time for all work items in our system, of course, right? Because all work items have to pass this column, okay? So higher lead times means worse time to market and potentially a higher cost of delay. However, if we introduce this review column here, here in the test column, we don't have that much work, and the items that were actually blocked here, they are finished faster. So the lead times for the potential defects are lower. Lower lead times means better time to market, which is actually less cost of delay, right? And yeah, we have to spend less effort in the test environment. So, is it economically meaningful to implement this solution? Yes. I think there's only one true answer. I have no fucking clue. Right? I mean, I cannot answer this question. I'm sorry. Well, the good news is there is simulation software on the market. And we could simulate this, right? You probably know this piece of software. You can download it for free. That's the good news. From focusobjective.com, so it's free software. Troy McGannis developed this tool, and what you can actually do is you can simulate, you can actually feed it with informations like cost of delay, like total cost, like revenue, lead times, blockers, defects, and so on and so on, and then you can just simulate possible outcomes, what it means if you are actually implementing this solution. And the output, actually you can configure it with a quite easy accessible XML document, and the output is something like this. You really get concrete economical figures out of this simulation. And yeah, it makes sense that you always simulate the current system, and then there was the example that we want to get rid of the user acceptance test bugs, right? So then you simulate it. What if you have the bugs actually, and what is the outcome if you totally eliminate them? And yeah, somewhere here you will land, right? So your saving is somewhere between 10 to 30,000 euros in this case. Well, it's a simulation, but it's a figure we have in hand, right? And it totally helps us to make economic decisions. Yeah, I can only encourage you that you really download the software and play around a little bit. It's not rocket science. So Troy did really a great job. There is plenty of examples in there, and you really get very quickly into this thinking here, okay? All right, so yeah, where are we? Well, blocker handling. Collect and cluster blockers is the idea. Then it's a good idea that we understand the problem of this cluster, actually. We find a solution for the cluster, and then we evaluate the cluster. We don't solve the cluster immediately. We think about the consequences. It's a good idea that we only solve clusters that are constraining our system, that we weigh effort against impact, and economics is our friend, okay? Think economically. Well, what else can we consider, or should we consider? Some pragmatic stuff here, cadences. When are you actually doing this blocker clustering? Well, there's some kind of, no, there is an actual trade-off between the quantity of blockers and doing it in a narrow time frame. So if you are doing this blocker clustering after a year, and you have blockers of a year somewhere on the table, maybe a lot of them are no longer valid because your system just changed, right? However, if you're doing a blocker clustering with 2 blockers, you are done very fast then, right? So yeah, you have to find a trade-off. So I'd like to recommend to start on a 4-weekly cadence, and then just to adapt what makes sense, actually. It totally depends on which flight level you are. And yeah, on team level, you usually get more blockers and so on. Yeah? Also maybe a good idea, yeah? I think everything is allowed here, yeah? So I try to start with this 4 weeks, and then we see what's going on, right? So what else? Yeah, you need some kind of meeting format. So where are you actually doing this? Well, I'm not a huge fan of inventing new meetings. I'm pretty sure there are some improvement meetings already in place. Use them, okay? Participants, yeah, all those who actually carry information about the blockers. One more thing here. Regarding tracking your how's it called? Improvements. What we are always dreaming of when we are actually doing this improvement stuff here, it's nothing more than improvement work, right? We're always dreaming about this J-curve. Everybody knows this awesome, famous J-curve, right? So the idea is when we introduce change that our performance drops, and we bring it up in the J-curve again. And then we are doing the next change, and the next change, and the next change until we are in heaven, okay? And everything's just fine. What I see quite often in reality is that you are doing your change, and then before even you gain the benefits of the first change, you start the next change. Then you start the next change, then you start the next change, then you are fucked up, right? So, sorry, I said fuck quite a lot, right? You know, I was in New York a couple of weeks ago. I was speaking at the Lean UX conference, and it was really, there was some kind of competition, the fucks per minute, I think. I did a good job. Yeah. Okay, so the whole point behind this is track your improvement work, right? So don't start too many improvements. Also, when it comes to improvement, it's stop starting and start finishing, okay? What I like to do is just to have some kind of improvement area on the board. And I think about what is our improvement flow. So when we're doing improvement, there's some kind of flow. So here we have probably something like prepare, then we realize the actual improvement, and then we validate it if the improvement is an improvement or not, or if the change is an improvement or not, right? And yeah, limit also your improvement, because you don't want to go down on the J-curve, you want to go up, okay? That's, I think, also a very important thing to do here. And, well, that's actually everything I wanted to tell you. Today, there was a, Troy and I wrote a, what is it called, article about this stuff. Today it's published on InfoQ. There's the link to it. And yeah, thanks also to Troy McGannis, who really, yeah, who helped me with this whole blocker clustering stuff, and a really big contribution from him is also into the slides, actually, in terms of knowledge. Okay, that's it. Thank you. Okay. So we have 2 more minutes for questions. Are there questions? Sure.
So if the future of management in the lean Kanban world is shifting from work director to flow enabler, what are some management behaviors that you have seen which help encourage the kind of behavior that you've described today, or discourage it?
Wow. I don't know. I'm sorry. Yeah, I have a lot of good answers. One more question. So I think we're over. Okay, thank you.